Ariane space flight number 158 will lift off from the pad in just 17 minutes. Well, 15 minutes, actually. Ariane can fly all missions, as you know. We're doing something a little different tonight. Because of it, the broadcast is in two parts. This first part will be 35 minutes long. We'll take you down through final countdown to liftoff over to plus 15 minutes after the liftoff. We're going to continue meeting some of the key players, two men who work in tandem, the DDO and the mission director. The DDO, Thierry Vallet, is his second mission as DDO, and Dan Murray dealing with the customers. We're going to hear from him now on tonight's mission, Flight 158.
The Rosetta probe is on its way to a first in space exploration, a first in human history. It will sound a 100-kilogram lander onto the comet's surface. For this purpose, Arianespace will provide an Ariane 5 generic plus version that will deliver the spacecraft on a liberation trajectory. The probe will then travel through the solar system, using the gravity assistance of Earth and Mars in a 10-year journey to meet the Churyumov-Gerasimenko comet. The flight will last 2 hours 30 minutes with a long ballistic phase of 1 hour 45 minutes after the first stage extinction. At the end of this phase, the second engine will be ignited to give the proper velocity to the Rosetta probe before its separation at the injection point.
Just to continue with the roadmap for tonight, after our first part, we're going to break for about 1 hour and 3/4, and we'll be back for part 2 of the mission on the broadcast, which will last about 40 minutes. 2 hours in all, a little more than 2 hours, from launch to satellite separation. Over to the commercial side now. Every Ariane space flight has its program director. That's the customer interface, program director and an assistant, or a second. Tonight it's Alex Madembasi is on the job, and he's going to explain why we have not a launch window, but tonight instead a launch instant. Alex. In most cases, Arianespace's mission is to place satellites in an elliptical geostationary transfer orbit around the Earth. In such cases, we have a launch window available in which any moment is possible for launch. For Rosetta, we must leave the Earth, so the orbit is not elliptic, but hyperbolic. To define this orbit and to communicate to the satellite the speed and orientation it'll need for its ejection point, we must define a single instant for launch, which we call H0. So why 2 launch instants? Well, we defined 2 trajectories very close to each other, which correspond to 2 launch instants, H01 and H02, separated by 20 minutes. Because of inevitable uncertainties on the launcher's propulsion parameters and flight profile, a trajectory that lets us attain an injection point is linked to a success probability equal to or greater than 99%. For the first launch attempt, we decided to favor the success probability factor, and since H02 had a slightly higher one, it was chosen as the unique launch instant. For the upcoming launch attempt, to minimize the risk of a red due to the weather, which would stop the countdown, we decided to favor the availability of the launcher at liftoff and have therefore 2 separate launch instants, H01 and 2, with H01 being the first. Meeting the final one of our key players in tonight's launch, we're going to hear from the launch operations manager. His name is André Sicard. He's the COL. He's up at the CDL, 13 kilometers from here. He's going to fill us in on the launcher campaign.
The beginning of the Rosetta campaign at the start of the year was atypical because we had a launcher erected last year. We kept the central core stage and the boosters. We erected a new vehicle equipment bay on upper stage to begin this campaign. We started by checks on the main stage on boosters, then we proceeded with the normal campaign. Another particularity of this campaign is the combined operation phase for this Rosetta single launch of 11 days instead of 7. This is required by the satellite's specific needs once integrated on the launcher. For the final countdown on the synchronized sequence, we don't have a launch window, but a single launch instant. The teams are very motivated by the challenge represented by the Rosetta mission.
The COEL's job is to manage launch operations, such as the final filling and the final checks before liftoff. Over again to Alex Madembassi for words on the satellite campaign now, and we'll be back.
The Rosetta mission is a very unusual one. As you may know, the spacecraft arrived in Kourou in September 2002 for a launch initially scheduled in January 2003. After the launch postponement decided in January 2003, the satellite's operations were interrupted and then modified so that the spacecraft could be ready for the second mission. The satellite remained in the preparation building, and one of the propellants was drained out for safety reasons. Some equipment was dismounted and some was rechecked before the resumption of the launch campaign. In October, the Rosetta team resumed the operational activities in order to be ready on time for combined operations with the launch vehicle. As of today, the preparation status of the spacecraft is excellent. It stands on the launch vehicle and all the checkout and controls have been successfully performed in accordance with the launch planning.
Ariane 5 stands 46 meters high. The boosters, also called the EAPs in the foreground there, stand 31 meters tall. Ariane 5 comes in, it's built in two parts. They call them composites. The lower composite, made up by the core central cryogenic stage and the boosters, and the upper section, which will ensure the latter second half of the mission, the upper stage and the payloads and the vehicle equipment bay. We're coming up on the 7-minute mark shortly, and you will hear the DDO, the Range Operations Manager,
attention pour le début de la séquence synchronisée.
Call out the 7-minute mark, the beginning of the automatic sequence.
Top, H0 moins 7 minutes.
All right, Thierry Vallée has called out the synchronized sequence, also called the automatic sequence. This is one of the final milestones in the final countdown. What's happening is the computers are taking over. There are two computers. They're up at the CDL where we saw André Sicard a moment ago, and they're checking out the electrical systems and the fluid systems. The 1,001 plus things to be looked at and verified and monitored before we can lift off. They will take us down from -7 minutes to -5 seconds. And what is happening basically is the launcher and the ground installations are gradually being put into launch configuration. You see the green status panels there? All is ticking along smoothly. This synchronized sequence is a rather crowded schedule. It leaves a margin, but not a big one. If we take too long to perform one operation, we stop the countdown and we will resume at -7 minutes again. These computers are loading the exact ignition time into the onboard computer. That happened at -6 minutes and 30 seconds. They're also checking out the more hazardous items, such as the pyrotechnic cords, which are used for separating the boosters and separating the fairing. We're going to go again to Jean-Yves Le Gall, who will fill us in on the stakes for this very important year of 2004 for the company. First launch of the year for Arianespace, 2004 will be extremely important for Arianespace with three major highlights. The first took place last February 4th at the European Space Agency meeting that ratified the support plan for Ariane, the EGAS plan, European Guaranteed Access to Space. EGAS will allow Arianespace to be on the same level as its global competitors, so this plan is very important for the future of our company. The second decision, also taken on February 4th, is to finance a Soyuz launch pad here in French Guiana. This launch pad is currently under construction, with the first launch set for the end of 2006. From then on, the Soyuz launch vehicle will be a perfect complement to Ariane 5 for Arianespace. The second highlight of this year is taking place now, with the launch of the Rosetta probe. Arianespace is very proud to participate in this project. Rosetta is one of the most ambitious projects ever for global space astronomy. Sending a probe for a rendezvous 10 years later with the 67P Churyumov-Gerasimenko comet is something we're quite proud to contribute to. We're certain that in 10 years, Rosetta will bring a harvest of extraordinary scientific results to the world scientific community. The third highlight of 2004 will occur later this year, probably in the summer, with the launch of an Ariane 5 ECA. The first flight of the Ariane 5 ECA in December 2002 was not a success. Since then, the entire European space community has mobilized to try and understand what happened and what went wrong, and to bring corrective action. This work is underway and will soon be completed. Today, preparatory work for this launch is going on at a good pace, and I'm sure that this flight will be a success that will give Arianespace a tremendous launch vehicle, one capable of launching 2 spacecraft as soon as they arrive here in Kourou, the European spaceport. I'm sure that the next 20 years will be as brilliant as our first 20. Coming up on 3 minutes, you're watching Arianespace flight number 158. Remember, you can follow us on the website, arianespace.com. The first launch of the year, as Jean-Yves Le Gall said, the last was an Arianespace Soyuz flight, Flight 162. The Amos telecom-sat for Israel went up on a Soyuz just after Christmas. Tonight's also the first launch for a liberation orbit, and when we get a moment, we'll get back with an explanation of that. Before, however, we're going to go to some shots taken yesterday of the rollout to the launch pad of the Ariane 5. The door of the final assembly building you see here opens up at minus 44 hours, and the launch vehicle and the table are transported at minus 42 hours over to the pad. There's a rail track, as you can see, that runs about 1 kilometer from the final assembly building over to the pad. And Arianespace rolls on the track at under 5 kilometers an hour. Takes about an hour to make the journey, but it takes the rest of the day to do the hooking up of all the fluid systems and the other systems of the launch vehicle. That truck you saw pulling the launcher fueled weighs almost 600 tons, and the table weighs another 800 tons, so the total is 1,400 tons. The weather over Kourou, you can see a little bit of cloud cover, not too much. Over the Atlantic, north and east, we're launching east tonight. It's very clear, so we look to have a clear sky and a spectacular launch of the Ariane 5 in just a little more than a minute. You'll hear the DDO call out that 1 minute mark, and we'll be...
À tous de DDO, attention pour H0 moins 1 minute. Top H0 moins 1 minute.
We're into the final 60 seconds of this very ambitious Rosetta launch for Arianespace and the European Space Agency. The final ignition sequence, you want to just brief you on that so you can be on the lookout for it. The main stage, the Vulcan 1 engine, will be ignited at H0. You'll hear the DDO call out to décollage, or allumage, sorry. The computers then, what happens is the computers will check out the pressure and the parameters for about 7 seconds, and they'll give the orders to ignite the boosters at plus 7 seconds, which is the point of no return, and then we will have liftoff. So we'll let you watch that. You'll hear the
DDO. Prêt pour le décompte final.
You'll hear the DDO call out the final 10 seconds. Enjoy the liftoff, everybody. We'll be back.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Décollage. Les paramètres bord sont normaux.
All systems go, says the DDO. You saw Ariane 5 came roaring off the pad rather swiftly, too. She takes off at a good clip. She rose about 12 seconds and rolled over for to get the final, the optimum trajectory going east, also for better radar reception. Lighting up the night sky over there. You see she's racing through the clouds now. On her way, sending Rosetta on her mission. The mass at liftoff, 750 tons. The core stage and the two boosters are burning now. Each booster, 238 tons of solid fuel. They will burn for 2 minutes, another 30 seconds roughly, burning 2 tons of fuel per second. See all eyes that are watching the screens. Very focused here in Jupiter Mission Control. The boosters also supply 90% of the thrust. They give a boost for Ariane to leave the atmosphere. Without the boosters, the core stage is not enough to get Ariane off the ground. They also support Ariane 5 when she is sitting on the pad. The boosters, very carefully built to be able to burn exactly symmetrically and give a parallel thrust for the launch vehicle. The EPC, core stage, and the EAPs built by our friends at EADS, the Vulcan engine by SNECMA, and the EAP engines by Euro Propulsion. Coming up on
séparation des étages d'accélération à poudre.
As I was going to say, the DDO said it first, separation of the boosters, roughly looking like this. They're separated by these pyrotechnic cords, which push the boosters away from the core stage, which is still burning. The boosters will fall into the Atlantic, some 500 kilometers from the coast. They are never reused. They're rarely recovered, sometimes for analysis purposes, but not tonight. All systems are go, coming up on 3 minutes. Next up, you'll hear the DDO call out the jettison of the fairing. The fairing stands 13 meters tall and weighs 2 tons. It protects the payload from pollution, dangers, and heating up while it's awaiting liftoff on the ground.
Largage de la coiffe.
And there goes the separation of the fairing. Again, separation systems using the pyrotechnic cords, separating the two halves of the fairing, 2 tons that we don't need now. They protect the satellite from the elements in the atmosphere. The separation occurs roughly 100 kilometers up, about 1,000 kilometers out. As I say, when the satellites no longer need the protection of the fairing, the 100-kilometer mark altitude is a general agreement on the part of the international astronomical community to distinguish between sky and space. All is nominal and normal on board at 4 minutes into the launch. We're dropping stages into the Atlantic. One of the reasons that this Kourou site was chosen as the European space base when they decided to build here in the 60s was the ability to have this wide opening over uninhabited areas and over oceans. We're going to go now to Antoine Beauvoir, the CEO of Astrium.
Rosetta is certainly the most complicated and ambitious science
program ever launched in Europe. Not only is this mission critical because the most complex part will be carried out in 2014, but we have been led to develop a spacecraft which has a large degree of autonomy, which can look after itself, because we cannot manage this spacecraft in real time. We have also been led to develop new technologies for the power due to the distance from the Sun. So a number of technical and program challenges which have been led by Astrium. This program is a true European program, as Astrium is a true European company. This program is also the confirmation of the leading role of Astrium on the interplanetary exploration programs. Mars Express has been a great success. Now we launch Rosetta, and Venus Express program is under development within Astrium and within our partners. So we establish ourselves as a key contributor to support the vision of ESA on interplanetary exploration scientific programs.
Astrium, the prime contractor for Rosetta, also with EADS, builders of the vehicle equipment bay, which is riding on the upper composite now. We're 6 minutes into the launch and all is going well on board. Take a look at the bottom left-hand corner of your screen. You've got some numbers and some letters. On the top you see the T, which is the elapsed time since ignition, and a little lower down the A and the V. The A is the altitude, approaching 160 kilometers now, and the V is the velocity, the speed, 4 kilometers per second. Over to John Elwood now, Satellite Mission Director, for our first look at Rosetta.
Once we've launched Rosetta from the Ariane 5 launch vehicle, we have to try and get the spacecraft out into the same orbit as the comet. Now, this is not such an easy thing to do. So in order to get the energy to do that, we actually have to fly by the planets. We fly by Earth 3 times, and we fly by Mars once. Each time we go around one of these planets, we get more and more energy, and rather like a slingshot, we try and get the satellite so that it is going out as far as Jupiter, and then when it is that deep in space, it can actually come in with the comet, and we can rendezvous and go alongside it for the 2 years. On our way out towards Jupiter, we also go through the asteroid belts twice, and so as we go past, we'll have opportunities to find asteroids. There's a lot of those around there, so that we can actually do some close-up studies of asteroids twice when we go through the belts. Now, this long mission, once we're coming in alongside the comet, we want to put a small lander onto the comet's surface. Again, another first for the European Space Agency. So when we come alongside the comet, we'll look at it, we'll map it, and we'll come closer and closer to the comet's surface. For a few months, we'll decide where we're going to put the lander, and then we very gently let it go, and it will fall onto the surface, where it'll grip the surface of the comet. And not only then will we have scientific measurements from orbiting the comet, but we'll have some ground truth actually on the comet's surface.
There's David Southwood, who's ESA's science director. We'll be back with 2 interviews from David Southwood a little later on. For now, we were speaking about the information on the lower left-hand portion of your screen. It comes from the launcher's telemetry. Ariane 5, as we mentioned, is autonomous now. The onboard computer continually calculating Ariane's speed and position, and can even can take a decision to correct any deviation from its trajectory. The trajectory, which the DDO has just said is normal, is designed to ensure that the launcher is always visible by the ground station tracking it. The first to track it is here in Galileo, at just behind us here, and the DDO has just called out. We've been picked up by our first downrange tracking station at Natal, over the border in Brazil, a station run by the Brazilian Air Force. There'll be roughly 6 stations following the Ariane 5 tonight as she makes her way across. The EPC is the only propulsion now burning. It'll burn for a total of 16 minutes, 160 tons of fuel. The EPC itself weighs 12 tons. It's carrying this fuel, liquid hydrogen and oxygen, very cold cryogenic fuel. We mentioned the liquid oxygen is minus 160 degrees and the hydrogen minus 250 degrees. This cryogenic fuel used, by the way, for the first time outside the U.S. on Ariane's very first launch in 1979. To continue a bit with the telemetry, there are roughly 600 parameters coming into the telemetry stations continually. They're recorded and analyzed right away, and they can be reviewed after each launch to improve the launcher's performance. We've just had, I believe, separation of the EPC, the cutoff command followed by the jettison command a few seconds later, all that triggered, of course, by the onboard computer giving those orders. So the lower composite now, finishing its work, the EPC and the two boosters. The upper composite, which is the EPS, satellites, and the vehicle equipment bay, will be taking over, but not right away. At roughly 11 minutes into the flight, we are moving into a ballistic phase. Now, what's a ballistic phase? Basically, we're coasting. When the EPC stops pushing the Ariane 5, she will make nearly one orbit before falling into the Pacific near the Galapagos Islands. We're in just the beginning of this coasting phase now. It'll last about an hour and a half. Now, during this coasting period, no motor is functioning at all. Ariane is coasting in space. Now, why do we need the ballistics phase? It will help optimize Ariane's trajectory. She's roughly, as you can see, 250 kilometers altitude, and she's in a temporary elliptical orbit. When the EPS begins to burn in just under 2 hours, she will climb to 650 kilometers altitude, and here the pull of the Earth will be much less, meaning the EPS will need less effort to leave the Earth's gravity with Rosetta. So this translates into a gain of several hundred kilos in performance. In other words, without the ballistic phase, I think Rosetta would have to be much lighter than the 3 tons as she is, and several of the scientific experiments she's carrying would have to be left behind. We're picked up by the Ascension Island tracking station. That's the next one down the line. That's a UK island run by cable and wireless, an ex-NASA station sending its data back here. At the moment, Ariane's weight includes the Rosetta satellite, roughly 3 tons. The EPS, a little less, 2.7 tons, and all the fuel, 10 tons, for a total of about 15 tons, riding now. During the ballistic phase, we'll be picked up by our extra ground stations, Ascension Island you just saw. Malindi, over in Kenya, will get the signal at plus 21 minutes, roughly. And after that, an Australian station at Dongara at plus 48 minutes. And finally, the last station at 1 hour and 45 minutes after liftoff, South Point in Hawaii. We're still coasting. We're coming up on the end of the first part in a few minutes. And then what will happen is Jean-Yves Le Gall will make his way out to our side of the... Here's Mr. Le Gall. Now he'll make a statement, and then we'll get a replay, and we'll be back at, I think, 6:17 Kourou time. So until then, the next voice you hear will be Jean-Yves Le Gall.
Donc, comme vous l'avez vu, la première partie de la mission s'est bien passée. Et à présent, Ariane 5 a mis sur l'orbite de parking le PS et Rosetta. Le PS et Rosetta vont rester sur cette orbite jusqu'à 6h14 heure de Kourou, c'est-à-dire 10h14 heure de Paris, moment auquel le PS s'allumera. D'ici là, la vidéotransmission va s'interrompre et elle recommencera vers 10h05 heure de Paris, quelques minutes avant la reprise des opérations. Donc merci, et puis à tout à l'heure pour la fin de la mission.
This is an English soundtrack from Kourou, Centre Spatial Guyanais.
Welcome back to Ariane Space Flight number 158, Part 2. The mission continuing now after the break. We're once again in the Jupiter Mission Control Building, the nerve center of the Guyana Space Base. Along with the major players, we're set to move into these final segments of the Rosetta mission.
You will be tonight with Mr. Pierre Junior and Pierre Collet for the French commentary. The English commentary will be done by Mr. Joshua Jean-Paul. You can also follow our broadcast on our website www.arianespace.com.
In this part of the broadcast, we'll look closely at the Rosetta probe itself and learn something about the European Space Agency.
We'll give you more details on the Rosetta probe and the Philae lander, which are now in their starting blocks for their 10-year trip to the comet Churyumov-Gerasimenko.
We'll also be bringing you a replay of the liftoff you saw earlier. All that coming up. Well, we hope you enjoyed the break. If you just joined us for Flight 158, we had a perfect countdown, a beautiful, picture-perfect liftoff, although we did lose the launcher rather rapidly into the clouds, but no matter, everything has gone according to plan. The boosters functioning perfectly, jettisoning on time, the fairing likewise, and the EPC, the same story there. We're at the end of the ballistics phase now. Here in Jupiter, all is, I guess you could say, calm but focused, is the way to describe it. Ariane still orbiting the Earth. We're waiting for the last boost, which will send Rosetta toward her first flyby out at Mars. That should be coming up shortly. This part of the broadcast will be 40 minutes long, the whole show 2 hours from launch to satellite separation. Over to Alex Madembasi again for a look at this final part of the mission.
Regarding the preparation of the mission and the trajectory itself, the February 2004 mission for the Churyumov-Gerasimenko comet is similar to the Virtanen mission of January 2003, but a number of parameters had to be adjusted. All this has required an unusual amount of work and human resources from Arianespace and its industrial partners, but also from ESA and especially ESA in Darmstadt. Their specialists have continuously worked with us in order to adjust the trajectory parameters, which will allow us to deliver the spacecraft on its proper escape orbit, with the required velocity and orientation. All this having been, of course, computed with respect to the Ariane 5 Generic Plus performance.
Rosetta has made now nearly one orbit, not Rosetta, Ariane, with Rosetta has made nearly one orbit around the Earth. We'll be back with more on Rosetta, but we're going to go to a replay of the launch that's coming up.
7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Décollage.
Well, those fine shots of the launch are letting you relive again those very dramatic moments, the very beginning of this interplanetary mission, very important one for Europe and for European science. We were saying that Rosetta completed nearly one orbit of the Earth in about 15 minutes. Will be picked up by the Kourou ground tracking station again, which is the first station to track the launcher at liftoff. We are now still in ballistics phase, also called the parking orbit, and the launch vehicle in what they call barbecue mode, which means it's turning just like on a spit, like on a rotisserie. The complicated mission, as you know, everything has to be calculated 10 years in advance for the long trip out to past the inner planets. When we get a moment, we'll look a little more closely at Rosetta with David Southwood and some others. But for now, maybe we could say a word about comets generally. One reason for visiting a comet, we're told, is that they have essential information about the origin of the solar system. And they're the most, scientists tell us, the most primitive objects in the solar system, and we'll hear more about that from David Southwood on that shortly. But their chemical composition hasn't changed too much since their formation. Comets' composition reflect, they say, that of the solar system when it was very young and, quote, unfinished, unquote, more than, well, many billion of years ago. By orbiting Comet 67P and by landing on it, Rosetta will allow us, they say, to reconstruct the history of our own neighborhood in space. We've just had, the DDOs called out, the ignition of the upper stage, which is very good news. So the upper stage, the EPS, coming on as scheduled. Final part of the mission, the EPS, the only propulsion now, will burn for 17 minutes. What's its role? Well, adjusting the satellization of the payload so it can reach its target orbit ensuring the right orientation for separation. There's David Southwood. We'll hear from him in just a minute. The 10 tons of storable propellant, a very different propulsion system than the EPC, the core stage, which is cryogenic fuel. This is storable propellant. The upper stage has a lot of work to do, unique work for the to take Rosetta on its way out to 67P. For the first time, this upper stage has to reach a speed of almost 40,000 kilometers an hour. That's the escape speed, the liberation speed for the mission, and it's the only speed, they say, that will allow leaving the Earth's orbit and pushing Rosetta out on its journey into deep space. The upper stage had to be remodified, requalified for this, for the delayed ignition. 40,000 kilometers, but even that, they tell us, is not enough to inject the spacecraft directly on its way towards the comet, which is why the spacecraft has to gather all this momentum 4 times, the 4 flybys, 3 of the Earth next year in 2007, 2009, and the 1 by Mars. All is functioning normally on board the EPS, we're told. You can see on the upper left hand, well, we'll get back to that in one moment. For now, the first part of 2 interviews with David Southwood. Dr. Southwood, many people are wondering, why do we need to go to a comet?
Well, we're doing something really basic. We're going back to the beginning of time, or the beginning of our solar system. We're trying to look at the material from which our solar system was made. We're going back and trying to find material that hasn't been changed or processed in the time that the solar system has grown from a primordial gas into the sun and the planets that we know.
Can you give us some details on Rosetta's scientific program?
Well, we attack the comet in 2 different ways. Number 1, we go out to the comet, orbit it before it's started its display, before the gases start coming out as the sun heats it up. We then drop down a lander onto the comet, and a key element is the ground truth that gives us. We'll be watching from afar, remote sensing we call it, the gases coming off and the changes in the environment of the comet and the effect it has on the solar environment around it. But at the same time, we'll be able to check down on the surface what it is that is making those things. It's really scratching and sniffing whilst also watching from afar. We use the techniques of spectroscopy as well as imaging, and using spectroscopy we find the fingerprints of the material that makes up the comet, that comes out of the comet, and that the relative amounts of material, of course, are critical clues in understanding the origin of the comet and the cometary material. There are those who say, well, we only have to look from afar, we can deduce everything. It simply isn't true. None of us scientists are that clever. It's very important to test and to cross-check, and the ground truth is for us a very central element of this mission. So the lander, so Philae, the lander, is really fundamental.
So you would say that Rosetta is for scientists, for the scientific community, and for the man and woman in the street?
Well, I hope it's people in the street as well as the scientists. I mean, you can take it the scientists are going to have lots of work, but the people in the street, I think it's very hard to imagine, if you're human, that you don't wonder sometimes, what's it all about? Where did it all come from? Once we were all stardust, how did we turn out to be the complicated beings that we are now? And I think we're looking for some of the clues that will help us put that story together.
How will Rosetta complement the Giotto program, which we saw in 1986?
Well, Giotto was really Europe taking its first shot into the solar system. And we staked our claim to cometary science by doing that. We went closest to a comet with the Giotto probe. It went closest to Comet Halley, and it just opened up the field of cometary science. Rosetta is very much the grand follow-up to that. It is the ultimate cometary mission. It's stimulated other countries to do cometary missions too. It's stimulated the whole of the world's scientific community in an interest in comets and in knowing you can do these things. So for me, Giotto is certainly the forebear of Rosetta, and I'm sure there are a lot of people here who worked on both missions who really feel this is the culmination of Giotto to be going off with this grand mission to a comet.
Once we were all stardust. That's a nice way of putting it. I started to say on the upper left-hand portion of the screen, you see the cursor. It looks like we're losing altitude. We are, in fact, going toward the perigee back toward Earth, which is, of course, quite normal. Here's a speed-up shots of all the flybys that are scheduled. 3 Earth flybys during the 10 years, a Mars flyby, circling the Sun 4 times, going through the asteroid belts twice. All this for the gravity assists. The first Earth flyby is next year, and the Mars flyby in 2007. 2011, comet enters, Rosetta enters a hibernation to be awoken in 2014. The program, some interesting notes, a €1 billion budget. The mission first approved in 1993. 14 countries involved, 1,000 people in Europe involved in its development. Of course, this big, ambitious project, putting Europe ahead in cometary science. 3 consortiums formed for it. The first was made around EADS, Astrium, and Alenia, developed and integrated the spacecraft. The second was a cooperative European effort led by the DLR, German aerospace research outfit, with the Italian Space Agency and CNES. We can go back to David again. We asked him what future ESA science programs we can be expecting, and here's his answer.
Well, we're going to Venus soon. Next year, we'll be launching to Venus. And that's actually very much a direct descendant of Rosetta. We're using a lot of the capabilities we've developed for Rosetta, both with Mars Express, that's at Mars right now, and with Venus Express that will be coming next. Beyond that, we come back to Kourou in a few years' time to launch 2 big astronomical observatories, Planck and Herschel. These are looking far out into the very beginning of the universe and the beginning of galaxies, and indeed also the beginning of planets. Those will be coming. They're going to be grand observatories for their time, and will take ESA back into astronomy again. Beyond that, probably the most important astronomical mission of the next decade will be the James Webb Space Telescope that we do in conjunction with NASA. Here, ESA is playing major roles, or Europe is playing a major role in development of instrumentation to go in the focal plane of the telescope, but at the same time, we're also taking responsibility for launching that telescope. Ariane will launch the James Webb Space Telescope in 2011 or 2012, and it's something I think every European should feel proud of, that we'll launch an American flagship.
Rosetta, some of the firsts on this historic mission. It'll be the first spacecraft to orbit a comet's nucleus, the first spacecraft to fly alongside a comet as it heads towards the inner solar system. Also be the first spacecraft to examine from close-up how a frozen comet is transformed by the warmth of the sun. And of course, the first to land in a controlled touchdown. We've seen some impact landings, but this is the first one that will be a controlled touchdown. The instruments on the lander will obtain the first images from the comet's surface and make the first in situ analyses to find out exactly what it's made of. On its way out to Comet 67P, Rosetta will pass through the main asteroid belt, so it will be the first European encounter with these. Over to the European Space Agency now for a look at that organization. To finish with the list of Rosettas first, there's a shot of the mock-up that's here in Jupiter. It'll be the first spacecraft ever to fly close to Jupiter's orbit using solar cells as the main power source. Now, normally, the traditional radioisotope thermal generators are used, but the new solar cell technology on the orbiter's two giant solar panels will allow it to operate 800 million kilometers away from the Sun, where the sunlight levels are only 4% of those on Earth. Now, there are two 14-meter solar panels on Rosetta with a total area of 64 square meters. On a lighter note, Philae, as you know, is the name of the lander. Philae is the island on the Nile, some of you may have visited it, where an obelisk was found that helped the French scientist Jean-François Champollion with the final clues, allowing him to decipher the hieroglyphics on the Rosetta Stone. And the main contributors to the lander, Germany, France, Italy, and Hungary, held contests for their 12 to 25-year-olds to name it. And the name Philae was proposed by a 15-year-old Italian youngster named Serena Vismara from a city near Milano called Arluno. The mom and dad of the comet, if we can call him that, Klim Cheryanov and Svetlana Gerasimenko, both Ukrainians, Mr. Churyumov from Kiev State University, and Madame Gerasimenko now at the Institute of Astrophysics in Tajikistan. Ms. Gerasimenko told us that she was one of Mr. Churyumenko's graduate students when they jointly discovered 67P. And it was, she says, her first time she ever went on any comet observation trips and got the picture. She said she was quite lucky. And I think that's a fair statement. Coming up on the end of propulsion, or the EPS. 1 minute propulsion left on the EPS. The DDO says everything is nominal on board. We're going to be picked up by the Kourou station momentarily. The station we mentioned earlier. It still doesn't mean Ariane is directly overhead, however. It hasn't quite made an orbit since the station will pick up the signal before as Ariane is approaching from the west. The Mission Operations Center during Rosetta's 12-year journey will be, as you know, at Darmstadt, European Space Operations Center, ESOC. New flight software there was tested on the spacecraft qualification model. Radio communications, here's an interesting note, between Rosetta and the ground will use a new deep space antenna, which has been built by ESA in Australia at a place called New Norcia. I hope I'm pronouncing that right. It's near Perth. 35-meter.
Extinction de l'EPS.
And there's the extinction of the EPS, right on time and right on target. And we're moving now into the orientation phase for the satellite in preparation for its separation in about, I would say, 1 minute. Orientation maneuvers, spinning up, etc. The new antenna in Norcia was tested on the Mars Express operations and performed very well, they say. Radio signals traveling at the speed of light will take, can anybody guess how long? We've been picked up by the Natal station again, so I guess you can say we've made an orbit. 50 minutes, 50 minutes will it'll take to cover the distance between the spacecraft and Earth. ESA is also building another antenna, 35 meters, also in Spain at Cervos, which will begin operating next year. The spacecraft will be visible from the New Norcia Australian antenna for an average of 12 hours a day. We're waiting for satellite separation now. And there you have it. The good news of the evening. The applause coming from the technical teams here. Good news for ESA, for Ariane, for European space. A great reward for all the teams involved in this mission, some for as much as the last 5 years. So after a letter-perfect countdown and a picture-perfect launch, Ariane 5 once again delivering. This latest in Ariane's launching of ESA science programs. While we're waiting for the speeches, we'll be hearing from Jean-Yves Le Gall, Arianespace Chief Executive, and by phone from Jean-Jacques Dordain, ESA's Director General. While we're waiting for them, we'll go to a replay first. We'll be back. Well, now that Rosetta has been separated successfully, some of the things going on, there'll be separation phases and orientation phases. That will take roughly 5 or 10 minutes, and by the time the spin-up has finished, we're at plus 2 hours and 20 minutes after liftoff. Malindi, the station in Kenya, will pick up the signal at plus 2 hours and 34 minutes. That's in about 15 minutes. And the final end of telemetry acquisition coming in at about 3 hours. Jean-Yves Le Gall for the first speech, to be followed by phone by Jean-Jacques Dordain.
Bien. Eh bien, bravo Ariane.
Bravo Ariane.
On a envie de dire après le succès éclatant
I'd like to
de
say
ce
after
vol
the success of this
158.
Arianespace flight number 158. Our launcher has just placed Rosetta on a liberation orbit, which after a trip of 10 years will bring it to the Comet 67P, Churyumov-Gerasimenko. I'd like to express my most sincere congratulations and my thanks to the European Space Agency and to Europe's scientists who have, once again, placed their trust in us. I'd like also to thank the technical teams at ESA, of course, but also at CNES, the Launcher Directorate, and the CSG. The teams from industry, and the teams from Arianespace. After the extraordinary image from Mars Express, which we launched last June, and after the launch of Smart 1, which is now on its way to the Moon, this success comes at the right time. Over the last few months, the European launcher landscape has changed considerably. On the institutional side, with fundamental decisions which guarantee a future for European launchers, support for Ariane, and construction of a Soyuz launch pad here in French Guiana. On the industrial side, with a major reorganization, which will let Arianespace continue to play a major role on the global space scene. And on the commercial side, with growth of the Ariane, Soyuz, and Vega family, and the agreements signed with our partners from the Launch Services Alliance. After these changes, we can look forward with serenity and confidence. And I'm convinced that our future will be brilliant, both here in French Guiana and in Europe. Once again, congratulations to everyone for this superb success. Without further ado, I'd like to give the floor to Jean-Jacques Dordain, Director General of ESA, who followed the launch from the agency's headquarters in Paris. Thank you.
Thank you, Jean-Yves. Just to say that the Arianespace mission is over, and I would like to thank Arianespace and the ESA mission staff, because I got the information that our operation center, ESOC, is now looking at the satellite. So we got the signal at ESOC. So another ESA mission is on its way to explore the universe. After Smart 1, which is en route to the Moon, Mars Express orbiting around Mars, Huygens approaching Titan, Rosetta is starting a 10-year trip through the solar system. So thanks to all these missions, ESA is demonstrating every day that we are already a significant partner of the international exploration of the universe. And we are even ready to be a more significant partner in the frame of the future international vision. We are working on that, not only on papers, but also with concrete missions. Now the spacecraft is in the hands of our ground controllers at ESA's Operation Center in Darmstadt. I know these hands are very good. My colleagues have established contact with the probe, and they will accompany it during its long trip. Rosetta is a real masterpiece of technology, developed by more than 70 European companies, led by Astrium, and managed by ESA Technical Center in Noordwijk. My thanks to all the engineers and technicians who are pushing technologies to the limit for responding to the dreams of scientists. Rosetta carries 11 scientific instruments developed by ESA member states with contributions from the United States, Greece, and Hungary. A huge scientific community has dedicated years of their work to prepare for this mission today. It is only the very beginning, and my thanks go to all scientists who have waited for 1 year and 3 days for that launch. Thanks to missions like Rosetta, space is part of our quest for knowledge and part of our dreams. But these missions would not be possible without a guarantee of access to space, and today this guarantee is provided by Ariane and Ariane Espace before being completed by Vega and Soyuz. As you know, we have crossed difficult times. 1 year ago, in the wake of the failure of the first Ariane ECA launch, Ariane Espace and ESA had to decide not to launch Rosetta. Such a decision has led to dramatic consequences for the scientific communities and for the ESA science program. I would like to thank the scientists and the ESA member states for their passions. And my personal thanks to Professor Wittig and DLR, which have built the lander of Rosetta, which will land on the comet in 10 years from now. We are not yet today back on track, since a lot of work has still to be done, in particular for launching the Ariane ECA next summer. But a lot of progress has been made. Ariane 5 generic is operational, as Ariane Espace has demonstrated today. Member states have materialized on the 4th of February the political decisions taken last May. A new industrial organization is shaping up, and industry has also materialized its commitments in reducing production costs. I would like to thank all actors who have worked days and nights for making such progress in 1 year. And in particular Ariane Espace, which is a partner of ESA for guaranteeing access to space, CNES, which is at the same time the major shareholder of the ESA launcher sector, our source of technical competence, and our host on the launch base. Industry, including all layers of industry in vehicles like Ariane, each tiny piece is important and contributes to the success. The European Commission, and in particular Commissioner Busquin, which has contributed concretely to the decisions taken on the 4th of February. And my colleagues from the Launcher Directorate, but also the Inspector General and all the experts which has contributed to the different commissions after the failure of ECA. Last but not least, I would like to thank all member states of ESA. It is not easy to take decisions. It takes time, meetings, discussions, but when the interest of Europe is at stake, member states always find the energy to overcome difficulties, and no one was missing on the 4th of February. Thank you for that. Today is the kind of day when I can forget the many days spent in this very room to prepare decisions. Today, the kind of day where member states get the best return of their investments, a new ESA mission is born. Long life to Rosetta.
Well, I think my Director General has said it all, but from my part, from the Directorate of Science, we now have yet another mission in space. Rosetta and its lander, Philae, are now off on their 10-year mission. I really am very grateful to everybody who's made this possible. We in Europe do things better by working together, and by the enormous number of people who've worked to make this unique, ultimate cometry mission. I've got to thank industry, EADS Astrium as the primes. I've got to thank Arianespace for doing such a great job of getting us on the right track. We've got 10 years ahead of us, but everybody who has contributed to get us to this point should feel very proud of what they've done. So thank you again to Ariane, to EADS, to all my colleagues in ESA, to all of the scientists who've had a very tough year coming to this final moment and who, frankly, have just got to begin now. They've got 10 years ahead of them. So thank you, everybody, and let's wait for 10 years' time when this really comes to an end. Thank you.
We're going to go, I think, to one last replay of the launch, and then we'll be back to say our goodbyes.
Sept, six, 5, 4, 3, 2, 1, top. Allumage Vulcain. Décollage.
All right, here in Jupiter, you could see the excitement on the faces of this memorable occasion. Reports coming in from the other observation sites across the base where the same thing happened, feelings of success and feelings of achievement. Doubtless those of you unable to be with us here experiencing something similar at your outposts around the world. A big night for Arianespace, for ESA, for satellite operators, for European space, and for European space science. Ariane 5 performing flawlessly, sending Rosetta on her way, and also helping Europe lead the way now in cometary science on this very important mission. That'll do it from Kourou. On behalf of everybody here, I'm Joshua Champa. Thanks for being with us. We'll see you next time.